So, hello and welcome to a new video. So, in today's video we are going to solve this particular integral here, which is composed by an exponential function and a polynomial of degree 2. And we are going to solve this integral by using the method of partial integration. And the relation for partial integration is over here. So, basically we have an integral of two functions. So, the derivative of a function f of x times the function g of x. And the relation says that, of partial integration, says that basically this boils down to the product of the function f of x times the function g of x, minus this integral where this time we have the derivative of the function g of x. So, we are going to use this method to solve this particular integral here. And so what we are going to do is we are going to identify this function here as f derivative of x and this function here as g of x. And with this we are basically ready to use this formula and relation here. So the relation says that we first have f of x, and this is quite simple, the integral of an exponential function e of x. E to the power x is nothing else than the function itself, so e of x times the second function g of x. So here we basically just have to copy the initial function. And then we have a minus sign, an integral, going over the function f of x, which, as already discussed, is nothing else than e of x times the derivative of this function. And this function here, the derivative of x squared, is nothing else than 2 times x. So we put the factor 2 in front of the integral and we have an x here. So, and then we can still not solve the function. We still have a product here of an exponential function times a polynomial function of degree 1 this time. So should not forget the differential, of course. So basically what we do is we just use the relation of partial integration a second time. So we copy the first term here, e of x times x squared, and then we have a minus 2, parenthesis. And then, again, we say that this function is f prime of x, so f prime of x. And this time, this function here is, let's call it h of x. So basically, it's the function that we are going to derive. So what we obtain here is f of x, so e of x, times the function g of x, or h of x, minus integral, so minus integral, f of x, which is nothing else than e of x, times the derivative of this function here, which is a constant 1. And then we have the differential at the end, of course. So now this is pretty easy because we just have to copy the first term here, e of x times x squared minus 2, parenthesis, e of x times x, minus, and this basically is nothing else than the integral running over the exponential function e of x. So the solution to this integral is nothing else than e of x. Parenthesis closed. Then what we see is that we have the function e of x within each of the 3 terms, so here, here, and here. So we can actually put the exponential function in front of the expression. Then what we get is a parenthesis. We have to copy the second polynomial function here, x squared. Then we should not forget the minus 2 times x, because the exponential function is already here. And then we have to make the calculation between minus 2 times minus e of x. E of x is in front of the expression. So what we obtain finally is nothing else than plus 2. So that's basically the solution to this integral here using the method of partial integration. If you have additional questions or comments, please leave your question in the comment section below. Please like my video and subscribe to my channel, and see you next time.